If you really want to get into data, you've got to learn to speak its language. And just like any language, it has a grammar, a set of rules that holds everything together. For data science, that grammar really boils down to one core idea: understanding attribute types. If you can get this right, you can unlock the amazing stories your data is waiting to tell.
Have you ever looked at a chart and just had that feeling that something is seriously wrong? Like, imagine a line graph trying to show the average eye color. You've got blue, brown, green, but what in the world is the average of blue and brown? The line might jump up and down, but it's telling you absolutely nothing. It's just nonsense, right?
And the reason it makes zero sense is actually super simple. You just can't treat all data the same way. Trying to find a mathematical average of something like eye color is like trying to add the word apple to the word orange. It just doesn't work.
And that, right there, is what we call the data type dilemma. When you get it wrong, you end up with confusing charts and models that are just plain flawed. But if you get it right, well, that's your first big step to becoming fluent in the language of data.
The best way to think about this is that data types are basically the vocabulary and the grammar of this new language. As soon as you know the rules, what the different words mean, and how they're supposed to connect, you can finally start having a real conversation with your data. You can start to hear the stories it's actually trying to tell you.
Okay, so where do we even begin? Well, luckily, it's not as complicated as it sounds. All data can basically be sorted into two big families, and understanding these two main groups is the first major milestone.
So on one side, you've got your qualitative data, which you'll also hear called categorical. This is all about descriptions, labels, and groups. Think names. On the other side, we have quantitative data, or numerical, and that's pretty much anything you can count or measure. It's the world of numbers. So let's start with the categories first.
So first up, let's look at qualitative data. This is how we describe the world, how we classify things into these neat, distinct groups. It's the data that answers questions like what kind or which one. Now, the simplest type of categorical data is called nominal. And a great way to remember this one is that nominal kind of sounds like name. That's all these are. They're just names, labels for categories that have absolutely no ranking or order between them.
And you see this stuff everywhere, right? Gender, eye color, the city someone lives in. In every single one of these cases, one category isn't ranked higher than another. They're just different. They're literally just names.
So, if you remember one thing about nominal data, let it be this. There is absolutely no inherent order. You can't do math on them. The only thing you can really do is check if two things are the same or if they're different. That's it.
Okay, next up in the category family is ordinal data. Now, just like nominal data, it's about categories. But, and this is the big but, the order of those categories suddenly matters a lot. There's a definite ranking involved here.
For instance, a PhD is clearly a higher level of education than a bachelor's degree, right? Or customer satisfaction. High is definitely better than low. The order makes perfect sense. But here's the catch. How much better? Is the jump from low to medium the exact same size as the jump from medium to high? We have no idea.
And that's really the perfect way to sum up ordinal data. You know the sequence, you know the ranking, but you just can't measure the space between the steps. The order matters, but the distance is totally undefined. All right, let's switch gears. We've talked about describing things with categories. Now let's talk about measuring things with numbers. We're heading into that second big family, quantitative or numerical data. This is where we finally get to start counting and measuring. First up in the numbers family, we have discrete data. The key word here is countable. Discrete data can only be specific, separate values, usually whole numbers. I mean, think about it. You can have 2 website clicks or 3, but you can't possibly have 2.5 clicks. It just doesn't exist. And this is the bread and butter of so much business analytics, isn't it? We're always counting things like customers, employees, transactions, clicks. These are always these nice, clean, finite, whole numbers.
But what if a number can be anything within a range? Well, that's where continuous data comes into play. If discrete data is counted, continuous data is measured. It can be sliced and diced into smaller and smaller pieces, fractions, decimals, the whole shebang.
Just think about things like a person's height, weight, salary, or temperature. These values exist on a smooth, continuous scale.
Someone's age isn't just 30 or 31. It could be 30 and a half or 30.52. You could get infinitely more precise if you really wanted to. There are endless possible values between any 2 points.
Okay, so nominal, ordinal, discrete, and continuous. We've got the 4 main data types down, but you're probably thinking, so what? Why does any of this actually matter in the real world? Well, this is where it all comes together. This is where the theory becomes practice, and it makes a huge difference. It turns out, knowing your data's language has a really clear 3-step payoff. First, it means you can choose the absolute right chart to visualize your data. Second, it makes sure you apply the correct statistical analysis. And third, all of this becomes the foundation for building an effective and accurate model.
And, this is not just some academic exercise. Knowing your data type is what tells you whether to use a bar chart or a histogram. It's what tells you if you need to run a chi-square test or a t-test. Getting this right is literally the difference between finding a real insight and making a massive error.
So let's just put it all together with a quick example. Imagine we have this simple data set. Now we can go through it column by column. Gender, that's just a name, so it's nominal. Education level, there's a clear order to it, so that's ordinal. Number of purchases, well, you count that, so it's discrete. And age or temperature, you measure those on a scale, making them continuous. See? This simple little exercise is the absolute first thing you should do with any new data.
And you really can't overstate how important this is. The stakes are super high. As one data scientist put it, getting the attribute type wrong isn't some tiny, insignificant mistake. It can throw your entire analysis off course, leading you to conclusions that are just flat out wrong and totally misleading.
But now you have the building blocks. You get the fundamental grammar of data. You know the difference between a name and a number, between an order and a measurement. So the only real question left is this. Now that you speak the language, what stories are you going to make your data tell?